Okay, Bismillahirrahmanirrahim. We start our lecture today with mathematical induction. Mathematical induction basically is a technique which is used to prove a statement. Okay, this one is to prove a statement lah. Okay, proof. Yeah, yeah. Nanti saya upload. Tak upload lagi sebab yang ni apa? Untuk minggu yang ke-9 upward nanti saya upload. Sekejap lagi. Okay, this one is used to prove a statement, a formula or theorem is true for every natural number. Okay, this one to prove statement for every natural number. Okay, and then step 2, it proves that if the statement is true for the n iteration or a number n, that is also true for n plus 1 iteration. This one for natural number and also for the iteration. Iteration. And then this one is induction, a method of proof. Okay. And then it does not generate the answer. It only can prove. For example, it is shown as a domino effects. Okay. It contains three parts. Firstly is a base case. It show it is true for one element. Okay, and then inductive hypothesis. Second one, you assume it is true for a given element. Must be clearly labeled. And then thirdly, show if it is true for the next highest element, inductive step. Okay, inductive step to prove that element true for the iteration. This one for the iteration. Okay, for example, show that n less than 2n for all the positive integers. Let Pn be the proposition n less than 2n. For the base case, show that P1 is true. So P1 is true because 1 is less than 2 power of 1 is equivalent to 2. Okay, this one is a base case. Okay, base case is to prove the most basic case. Okay, this one is base case to prove the most basic case. Okay. Okay. Second step is inductive step. Show that Pn is true. Then Pn plus one is also true. That we have the condition n less than 2n is true. So we need to show that Pn plus one is true. For example, we start from n less than 2n. Okay, therefore, okay, n plus 1 is less than 2n plus 1, less than 2n plus 2n equal to 2n plus 1. Okay, so that we can conclude n less than 2n, then n plus 1 is less than 2n plus 1. Okay, okay, this one is inductive step. Okay, okay, and then conclusion, then Pn must be true for any positive integers. Uh, and less than 2n is true for any positive integers. Okay, this one is induction example. Show that sum of the first n is odd integer is n power of 2. Okay, if n equal to 5, okay, and then we have a sum of it. Sum, okay, this one is sum of first and odd integer is n power of 2. Formally show, okay, we have this formula P1. P1 is equivalent to maximum is 1, whereby I is start from 1 to I. Sorry, this one is to I. I is minus 1, minus 1. Minus 1 is equivalent to 1 power of 2. And then the equation is 1 equivalent to 1. Okay, sum of the first n odd integer is n power of 2. Okay, we have first A1, A2, A3, and AN. So for the A1, 1, we have 1, we have 3, we have 5, and so on. And then for the formula n, we have formula 2i minus 1 is equivalent to n power of 2. Okay, this one is n odd integers. We add on, we get 1, we get 3, we get 5, and then we is 4 is equivalent to, we replace 4, 8 minus 1 is 7, and so on. Okay, this one is for the base case. Base case, P1 is true, so N1 is N equivalent to 1. Okay, so we can prove that for the sum of the first and odd integer is equivalent to n power of 2, 1 power of 2. Okay, this one is equal. Okay, and then for the induction hypothesis, assume that true for k. We assume that pk is true, or that k is the maximum for the I start from 1. This one is the formula, the terms. 2i minus 1 is equivalent to k power of 2. Okay, k power of 2 is equivalent to n power of 2. We don't know yet if this one is true or not. So we should prove it. Later I show to you. And then the third one is the inductive step. They have three steps. Please remember, for the induction we have three steps. First one is the base. Secondly is the inductive hypothesis, and the third one is the inductive step. We want to show the true for the k plus 1. So we want to show that the sum of k plus 1, whereby we start from I equivalent to 1, and then this one is the term. Okay, okay, we replace n power of 2 by k plus 1. So okay, this one is the formula. This the formula ai a1 plus a2 plus a3 plus a4 until a5. Okay, k plus 1. Okay, and then the formula 2i minus 1 is equivalent to k I 2i plus 1 plus ak plus 1. Okay. Okay, and then we list out from a1 until ak plus 1. So we replace this one k, okay, for this one. This one is total up. Okay, and then ak plus 1 is equivalent to 2I plus 1. Okay, and then ak plus 1 is equivalent to 2k plus 1. Okay, we replace this one to 2I. Okay, so k plus 1 to I plus minus 1 is the terms. Okay, is plus ak plus 1 lah. We replace this one because ak plus 1 is we replace the values k plus 1, this one we replace the n power of 2 lah. So the next one is okay, the sum of I k plus 1 ai is equivalent to sum of I k ai ak plus 1. Okay, okay, we replace it. This one is for ai, a2, a3, we list out. Okay, induction example to be continued. This one to recall the inductive hypothesis. Okay, we have ak is equivalent to ak 2k minus 1. Ak plus 1 is equivalent to 2k plus 1 minus 1. Okay, so ak plus 1 plus the sum of k to I minus 1. Okay, we replace this one. Okay, for the sum, we replace 2I minus 1. This one we replace ak plus 1. So plus here is k power of 2 lah. K power of 2 equivalent to k power of 2 plus 2k plus 1 lah. This one is inductive hypothesis. Okay. Okay, inductive hypothesis equivalent to k power of 2 lah. Okay. So k power of 2 plus 2k plus 1 is equivalent to k power 2 plus 2k plus 1. Okay, this one is the same. So if we recall back, this one is the same. Okay, it's true or not? It is true lah, because we replace k power of 2 lah. Yeah. Yeah. Sama dengan ni. Yang ni. We want to prove. We want to prove hypothesis lah. Inductive hypothesis is true for value of k lah. Tidak semestinya betul lah, tapi kita kena replace lah. Replace dengan ni 2i plus 1 minus 1 lah. Lepas tu kita mula-mula kan kita tengok yang ni tadi induction example ni kan. Kita prove kan, show that P1 is true by using the value 1. We can conclude that this one is the true lah, because 1 is equivalent to 1. Ni tengok balik yang atas Tengok balik yang atas ni. Base case show if it is true for one element. And then inductive assume that it's true for any given element. Must clearly label, must be show step by step. Then show if they're true for in next element inductive step. This one for the iteration. So okay, for the iteration yang ni kita gunakan induction proof or inductive step lah. Inductive step. We replace lah. AK is equivalent to 2K tolak 1 and then minus 1 and then AK plus 1 is equivalent to 2K plus 1 lah. Yang ni kita dah buat tadi, yang kat atas ni. Okay, kita replacekan dia. Boleh ke? Siapa yang tanya tadi? Famarita. Habis siapa Ya, Lewaton. Okay. Boleh ke? Lewaton. Dia nak prove inductive hypothesis tu ya. Lewaton. Okey ke? Nanti saya tunjuk contoh lain I show you another example. Okay, what we show that based on the case P1 PK was true, then PK plus 1 is true lah. We know that true for P1 because PK plus 1 is true for P1. Okay, and then we replace P2 true, P3 for and so on lah, for infinity. Thus, for it's true for all possible value of n lah. Okay, so we can conclude for the P1 and for all k, Pk implies Pk plus 1 is implies for all n, Pn. Okay, we can conclude this one. Okay, I'll give you another example after this. Okay, the idea behind the inductive proof is to show the base case first. Secondly, to show the inductive hypothesis, and thirdly, to manipulate the inductive step so that you can substitute in the part of inductive hypothesis by using the recall inductive step. And then the last one is show the inductive step. Okay, this one is the second inductive induction example. Show the sum of the first n positive integer, even integers is n power 2 plus n. Okay, so we have for all Pn, whereby the Pn is the sum of n, the sum of the max value for I equivalent to 1. This one is the term 2I is equivalent to this one. This one is the condition. Basically, to show to prove, we have three steps. First, base case. Second, inductive hypothesis. And then the third step is induction step. Okay, so for the base case, we replace by P1, we got same. This one is must be same. For the second step is we assume we replace by the k. 2i is equivalent to k power of 2 plus k because we want to replace this one n power of 2 plus n. Boleh ke? Okay, we replace by k. Okay, and then for the last one, we show the induction step by using the recall induction step. Okay, and then we replace k plus 1. Okay, equivalent k plus 1 to I is equivalent to k plus 1 power of 2 plus k plus 1. Okay, this one is to recall. Okay, to recall our inductive hypothesis. Okay, okay, this one is n power of 2 plus k for the first example. Okay, this one is the term. Okay, we want to prove this one is same for this one. Okay, so this one k plus 1, sum of I to I is equivalent k plus 1 power 2 plus k plus 1. So this one, okay, we replace 2k plus 1. Same goes to the step, this one. Okay, we recall inductive hypothesis. AK, okay, AK power 2, and then AK plus 1. Okay, for this one, okay, n power of 2 plus k. Okay, and then we have 2k plus 1 is sum of 2i, k is equivalent to I is start from 1. Okay, this one is minimum. Okay, then 2k plus 1 plus k power of 2. Okay, we replace k power of 2 plus k lah. And then we total up 2k plus 2 is equivalent to 3k, and then k power of 2 plus 2 is equivalent to this one. We open up. Okay, we have k power of 2 plus 3k plus 2 lah, is same. Okay, notes on the proof by the induction. We manipulate the k plus 1 case to make it part of a loop that the k case. So we replace the part of the other side of the k case. Okay, we replace this one. Okay, replace by k power of 2 plus k. Okay, this one. Okay. Okay, and then so we got k power of 2 plus 3k plus 2 is equivalent to k power of 2 plus 3k plus 2. Okay, and then this one is third induction example. Okay, we have question 7. Show that the total up of n I power of 2 whereby the minimum I equivalent to 1 is equivalent to n plus 1 2n plus 1 divided by 6. Okay, this one on the base case, normally we replace. We replace the value n equivalent to 1, and then we replace the n value. We got 1 equivalent to 1 lah. Okay. Okay, and then inductive hypothesis for the second step, inductive hypothesis. Assume that pk is true. Okay, we have k I equivalent to 1, I power of 2 is equivalent. We replace it. We replace the uh, value. K plus 1. This one we replace by k. Okay, we replace by pk plus 1. Okay. Okay, we replace k and then k plus 1 to k plus 1 divided by 6. Okay, and then third induction example, we want to show. Okay, okay, this one k we replace okay, we replace k plus 1 to k plus 1. K plus 1 k plus 1 plus 2k plus 1. We replace this value. by k. Okay, by this one. Okay, so we have here k plus 1 power of 2 plus this one, sum of this one is the term, k plus 1, we open up the bracket, okay, and then k plus 1, this one we replace by k plus 1, 2k plus 1 here. Okay, we will replace by this one, pk, okay, equivalent to k plus 1, k plus 2, 2k plus 3, and then when we open up this one, okay, divide by 6, and then this one is we divide also by 6, 6k power of 2 plus this one we cancel because we divide by 6. Okay, so this one is equivalent. Okay, okay, equivalent to 2k power 3 plus 9k power 2 plus 13k plus 6. Okay, okay, this one is same for this one. Okay, this one is third example is the case is going well, but what if the hypothesis was wrong? Hypothesis was wrong. First, we test the third rule, base case, inductive hypothesis, and then the third one is the inductive step. First one is we test base case. Base case must be same. So, but let's continue anyway. For the first one, if the base case is wrong, basically you don't go for the next step. But let's continue. Assume that PK is true. Okay, and then plus 6. Okay, this one. We can say this one is not same. Okay, when we replace this one 14k, this one 16k, it's not same. Okay, for induction example, uh, question 1 show the n is exclamation mark. It's not the same for n power n. For n, for all n is greater than 1. Okay, for the base case, n equivalent to 2. 2 is not the same for the 4. Okay, it's wrong. Okay, hypothesis assume k, okay, exclamation mark is less than k power of k. Okay, this one also not same. Okay, okay, this one you can see for the answer. Okay, for example, we have used the principal mathematics to prove that 1 plus 2 until n is equivalent to n plus 1 divided by 2 for n greater than or equal to 1. And number 2, where n is a non-negative integer. So first step is to show the proof that base case is all true, all true. Uh, for the we assume, okay, we assume case base is true. Okay, and then secondly, for the inductive hypothesis, assume that it is true for any given element. And then number 3, show that if it is true for next highest element. Okay, this one is the question 1, 2. Okay, question 1. Okay, question 1. Basically, you show the base case and 1. Okay, for I total 1, maximum I equivalent to 1, I equivalent to n plus 1, divide by 2 lah. Okay, so we replace this one by 1. We got 1. 1, 1 plus 1 divide by 2 lah. Okay, yeah, yeah, yeah. Kita ganti je nilai dah. Sebab untuk base case ni kita ganti nilai dia kepada 1 lah. Kita nak provekan dia. Provekan nilai I tu. Okay. Lepas tu for the inductive hypothesis number 2, we replace the PK. Okay, K kita ganti dengan K. K ni untuk nilai I lah. Okay. K I equal to 1 is equal to K plus 1 divide by 2 lah. So inductive step we show K plus 1 tadi, K plus 1 divide by 2. So this one K plus 1 we replace K tadi, yang ni tadi we replace K and then we replace K plus 1. Okay, this one this value. So K plus 1 divide by 2 lah. So we simplified K plus 1, K plus 2 divide by 2 lah. So for the induction step, we must recall this one. Okay. Recall K plus 1, K plus 2 lah. So that we have PK is equivalent to maximum is K, the term is I equivalent to K plus 1 divided by 2 lah, yang ni tadi. Okay. You recall and then for this one K plus 1, jadi yang kat sini tadi K plus 1 we replace K plus 1 and then K plus 1 plus K plus 1 divide by 2 lah. Okay. Yang ni tadi K plus 1 divide by 2 Okay. And then so we can have same here. Okay, so it is true. Okay, for the second inductive step, okay, we got for the base, question 1. Okay, and it's non-negative integer. Okay, same, we got same answer. Okay, we call inductive step. Okay, base. Okay, we got same also 2 equal to 2. Okay, first we have show the P1 or N1 n equal to 0. This one for the non-negative. Prove that 2 minus 2 multiplied by 7 plus 2 multiplied by 7 power of 2 and so on. Divide by 4 where is n is a non-negative integers. Okay, kita bagi contoh lain. Okay, another example. Another example. Okay, we want to prove that 1 plus 2 plus 3 plus plus n equivalent to n plus 1 divided by 2. Okay, so the first step apa dia? We want to prove the basic, basic that n equivalent to 1 lah. Okay, so 1 equivalent to, we replace the value before this one. 1 plus 1 divided by 2 lah. So this one 2 divided by 2, and then we got 1 equivalent to 1. Okay, yang sini faham ke? Do you have any questions so far for the basic? Huh. Uh, uh, Soalan kita tetapkan dia punya condition. Okay. In the question, they will state what is the condition for the to prove the mathematical induction. Okay. Okay, see the pattern. See the pattern. And then number 2, apa yang kita kena buat? Number 2, apa yang kita kena buat? Number 2 is inductive hypothesis. Okay, hypothesis. Okay, apa yang kita buat, kita mesti assume assume true for n value is equivalent to k. Okay, kita dah dapat tadi. We have shown 1 plus 2 plus 3 plus k equivalent to k plus 1 divided by 2 lah. So that show true for the n equivalent to k plus 1. So that we have 1 plus 2 plus 3 plus plus k plus k plus 1 is equivalent to k plus 1. Okay. K plus 1 divided by 2 lah. Yang ni tadi. Okay. Inductive. Hello? Ada yang nak tanya? Ni tadi, yang atas tadi ni? Uh, uh. Hmm. Diganti dengan nilai K. Diganti dengan nilai K ni. Kan tadi, kat depan mana? Ha, tadi yang mana? Ha, ha. Kita dah letak N di depan. Bukan kita yang ni kita nak provekan saja. Kita tak replace apa-apa. Kita kena ikut equation lah. Ini equation dia lah. N equivalent to N plus 1 N kurungan N plus 1 divide by 2 lah. This one we must follow lah. This one. We just to want to prove that N is equivalent to 1. That 1 equivalent to 1 lah. Yang ni kena pastikan dia sama dengan 1 lah. Yang ni kita replacekan saja nilai 1 tu. Yang ni baru kita buat replace K plus 1 tadi. Kita buat N equivalent to K plus 1. Lepas tu bila kita masukkan ni dalam kita punya ni tadi, yang atas ni tadi, kita akan dapat K plus 1 ni N kan tadi N plus 1, kita gantilah nilai K tadi tu, N plus 1. Nilai K tu kita ganti dengan N. Boleh? Tak perlu. Nanti kita prove by kita recall balik. Kan untuk yang contoh sebelum ni kan kita panggil dia recall. We recall back yang ni inductive step lah. Inductive step ni nanti kita recall balik kita punya ni lah. Sekejap mana hypothesis inductive ni. Show, lepas tu assume this one. Kita ganti dengan nilai K. Lepas tu nanti kita nak provekan dia lah. Kat sini. Sekejap nanti saya tunjuk. Kamu tengok dulu So yang ni tadi, this one K plus 1 divided by 2 plus K plus 1 is equivalent to K plus 1 K plus 2 divided by 2 lah. Okay, kita sambung. Okay, daripada sini tadi, from this, we have we divide by 2 lah. K plus 1 divide by 2 plus K plus 1 2K plus 1 divide by 2 lah. Is equivalent to K plus 1 K plus 2 divided by 2. Okay, so we we don't really need to look at the denominator, so they are same. So now if we can just show the denominators are same, then we basically completed the proof. So just we rewrite this one, we just rewrite back. Okay, k k plus 1 plus 2k plus 1 is equivalent to k plus 1 k plus 2 lah. Yeah, Bro Aisyah. Kenapa Aisyah lama masuk? Okay, so from here, okay, k k power of 2 ni k kat sini, k power 2 plus k plus 2k plus 2 is equivalent to k with k power of 2 plus k plus 2k, this one plus 2k plus k, this one plus 2. So we have k power 2, same with the k, same with the 2, same here with the 2k. Okay, jadi sama lah. Boleh? This one k plus 1 is the, okay, this one k plus 1 divided by 2 lah. And then we replace the k plus 1 here. Here lah. This one is the sum lah. Okay. The total the total of k plus 1 divided by 2 lah. This one. Okay. Okay, boleh ke? Okay, contoh lain Saya bagi contoh lain. Okay, contoh lain. 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 is equivalent to n power of 2. Okay, so we go for the basic. Boleh ke ikut saya ni, Aisyah? Okay, we replace 2n minus 1 is equivalent to n power of 2. Okay, and then we got n equivalent to 1. Okay, and then 2, 1. Boleh ikut ke? Dalam button boleh ke? Okay, this one for basic. Kalau tak faham nanti saya bagi lagi contoh. biar kamu faham lah. Yang mana? Yang ni. Ha. Hmm. Ya. Hmm. 1 tambah 5 tambah 3. Hmm. Yelah, sebab kita tengok pada uh, yang ni 2n minus 1 ni. Tengok yang ni. Tak, kalau kita buat n sama dengan 1, kita akan dapat 1 lah. Lepas tu kalau kita buat n sama dengan 2, kita akan dapat 3 lah. Ini dia punya term dia. Kan kita dah belajar. Ganti ni lah. 2 kali 3 tolak 1. Dapat 5. N sama dengan 3. Kan? Nampak kan? Yang ni. Kalau 2, kita dapat 3. Ni dapat 1. Boleh ke? Ni dia punya term dia. Term yang kita dah belajar last week. Bukan chapter berapa chapter 2 chapter sebelum ni lah. Kita dah buat term Term yang kita dah belajar sebelum ni, 2n plus 1 is the terms, formula term yang kita dah buat pattern is equivalent to n power of 2 lah. Dapat ke? Siapa yang tanya tu? Boleh ke? Okay, boleh saya teruskan ke? Basic Basic boleh Kita assume, we assume that n equivalent to 1 is 2n minus 1 is n power 2 lah. Okay, this one is the basic So the second step apa dia? Second step, induction Assume that we have 1 plus 3 plus 5 plus dot plus kita replace 2k minus 1 is equivalent to k power of 2 lah. Kita replace nilai n dengan k tadi. Ni replace n we replace n Boleh ke? We replace yang 2n tadi. Yang ni kita replace 2n minus 1 is equivalent to n power of 2 tadi. Okay, we replace Boleh ke? Okay, kemudian apa yang kita perlu buat? Show that true Apa dia? Show true for n equivalent to k plus 1. Okay, jadi show that ni kita ada we have 1 we have 3, we have 5, plus dot 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 dot, plus 2k minus 1. Okay, so 2k plus 1 kita pluskan dengan 2k plus 1 minus 1. Boleh? Okay, so yang ni tadi n power of 2 ni, k power of 2 ni kita buat kat sini is equivalent to k plus 1 power of 2 lah. Okay, so kita akan jadi apa? So this one, kalau kamu tengok this one sampai sini sama juga dengan sini sampai ke sini lah. So yang ni kita akan jadi so this one can be k power of 2 because of the here equivalent to n power of 2 plus two k plus 2 minus 1. Yang ni kita dah buka is equivalent to k plus 1 k plus 1 k power of 2 plus 2k plus 1 is equivalent to k power of 2. This one we recall back the inductive k power of 2 plus k power of 2 plus k plus 1. Okay, so okay, from here we got k power of 2 plus 2k plus 1 tadi plus is equivalent to k power of 2 plus k plus 1 k power of 2 plus 2k plus 1 sama lah. Same Okay, ada soalan ke? Ya. Yeah. Tak berapa dengar lah. Apa dia tu? Putus-putus lah. Tak, tak berapa dengar. Siapa tu? Daniel. Dan, Da- Daniel, type Daniel. Daniel tak berapa dengar Daniel. Kalau Daniel type boleh. Yang lain dengar ke? Daniel tak berapa nak dengar lah. Lain putus-putus. Apa dia Daniel? Kurang dengar. Kalau Daniel type boleh. Daniel type boleh. Yang lain tolong bacakan boleh? Okay, tak berapa dengar Daniel. Okay, this one is step basic. And then we have number 2 is inductive hypothesis. We assume. And then number 3 we recall. Show, we recall the inductive hypothesis. Sama je yang ni. We recall back. Okay. Okay, this one. Uh, 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 uh. Boleh ke? Okay, ada soalan lain ke? Kalau tak ada, saya nak bagi contoh lain. Do you have any question? Ha, ha, ha. Hmm, hmm, hmm. Yang mana yang ni? Yelah kita nak ganti nilai ni 2K tambah 1 ni. K tambah 1 ni. Kita nak ganti dia. Macam mana? Yang mana? 2K tolak 1. Ha, ha, ha. Yelah sebab kita nak ganti nilai N tu. N ni kan kat sini kan 2K tolak 1. Kan? Lepas tu kita nak gantikan nilai N tadi dengan K. Lepas tu kita nak gantikan pula dengan K tambah 1. Jadi bila kita gantikan K tambah 1, kita jadilah nilai K yang kat sini pakcik. Ha. Sebab itu ni kalau yang sebelum-sebelum ni kita buat dia sum lah. Apa? Kita buat macam ni, dia pening sikit lah. Kita sum K plus 1 sama je sebenarnya. Contoh lain macam ni lah. K induction, we want to prove lah K power of 2 plus K. Yang ni dia dah bagi siap-siap. Okay. Dia dah bagi siap-siap. Jadi yang kat sini kita nak ganti dengan K plus 1 tadi. 2K plus 1 yang ni lah. Yang ni. Okay. Yang ni. Okay. Jadi bila kita replace 2K 2K plus 1, yang ni kita ganti dengan K power of 2 plus K lah, sama je. Kita replace balik. Okay, another example saya bagi contoh. Kalau tak jawab juga exam betul ni, tak tahulah saya tak jawab macam mana. Banyak lah example saya bagi. Okay, show kita ada show 1 plus 2 plus dot plus n equivalent to n plus 1 divide by 2. Okay, kenapa dapat 1? Kita ganti nilai n lah. 1 tambah 1 2 okay. Bagi 2 dapat nilai ni. Okay, n ni. Okay, kemudian assume first one is basic. Basic, assume n equivalent to 1. So 1 equivalent to 1 plus 1 divided by 2 equivalent to 1 2 divided by 2. Okay, 1 equivalent to 1 lah. Okay, pada basic. Kemudian kita nak gantikan dia dengan K plus 1. So we assume that 1 plus 2 plus dot plus K is equivalent to K plus 1 divided by 2 lah. So K plus 1 is true. 1 plus 2 plus dot plus K plus K plus 1 lah. Equivalent to K plus 1 K plus 2 lah divided by 2. Okay, yang ni kita nak gantikan dengan K plus 1 N. Kita nak gantikan dengan N So 1, 2, 3, k plus 1. 1, 2, 3 ni kita nak gantikan dia. Jadi, so k plus 1 divided by 2 plus k plus 1 equivalent to k plus 1 k plus 2 divided by 2. Boleh ke? It is true. Ini. Jadi kita nak replace yang ni kat sini lah. Okay. Boleh eh? Boleh ke? So, kita dapat k power 2 plus k plus 1 divided by 2 equivalent to k power of 2 plus 3k plus 2 divided by 2. So, kita dapat berapa? K 2k ni 2k k power 2 plus 3k plus 2. This one silap. Plus 2 is equivalent to k power of 2 plus 3k plus 2. Sama kan? Okay. Jadi true lah. Boleh ke? Okay, ada soalan ke? Ada soalan ke, Shikin? Sazwana? Ada soalan ke? Ha. Boleh eh? Banyak dah ni. 10 contoh dah. Kita nak ganti je, replace. For this one, we go by the formula. We go by the formula. Okay. Okay, this one I show you this one and for the even integer rephrase Okay, for sum 2i equivalent to n power 2 plus n Okay, we have three parts. One base case is to prove this one is equivalent to 1 and then induction hypothesis. Okay, number 2 and then induction step to recall back the inductive step. Inductive hypothesis. So for this one, we continue P1 for sum 2i is equivalent to 1 power 2 plus 1. 2 is equivalent to 2, same. Okay. Okay, and then number 2, assume. We assume this one pk. We want to replace k. And then induction step, we replace k plus 1. Same by here. Okay, ak plus 1. Okay. Okay, this one k plus 1 is this one k plus 1, and then this one is here k power of 2. Okay, same kan, sama kan. Okay, and then k power 2 plus 2k plus 1, and then we replace ak plus 1 2k plus 1 minus 1 plus k power of 2 lah. Okay, this one is same lah. Okay, it's true lah. Okay, left and right is the same. Okay, class, do you have any